last week. The sound did not come through for whatever reason. I thought the microphone, once it was on me, that it would turn on Blueberry flashback, but apparently it didn't. Section 2.3, we gave the introduction on last time. I wanted to talk about how do you take the integrating factor and how does that integrating factor play a role with the solution. Here, before we start the problems, I want you to look at just these 4 steps, really 3, in terms of what you have to do to solve a first order linear differential equation. If it is linear, you determine or find the so-called integrating factor. How do you find the integrating factor? Well, it's based on how the equation is written. These equations, you want to be in this form: y prime plus some function of x times y is equal to some function f of x. So the integrating factor is always e to the integral of this coefficient of y that we call p of x. So that's the integrating factor. So you take the integrating factor, and there's a couple of ways you can do this. You can do it the long way. The long way is take the integrating factor, multiply it to every term in the differential equation, and that differential equation becomes exact. And then you would do the method of exactness. That's the long way. We don't want to do that. There's an easy way here. So the easy way is find the integrating factor, and when you do that, the neat thing is that the left side is automatically the derivative of the product of the integrating factor and the so-called dependent variable, which mostly it would be y, like y equal to some function of x. So the left side, and this is what this third statement here says. Take the integrating factor. It is multiplied on every side with every term, but we're going to stop there. Once you multiply the integrating factor to both sides of the differential equation, the left side is automatically the derivative of the product here, the derivative of the product of the integrating factor and the dependent variable y, if the function is a function, y equal to some f of x or some function of x. And the left side is the integrating factor times the function f of x. What you're going to do now is integrate both sides. The integral of the left side is, according to the fundamental theorem of calculus, the integral of a derivative is the function that is being applied on. So it's just simply the inside. So here, the fourth step says integrate both sides. Integrate this side. So the left side if I take the integral of a derivative, the result is just what's inside, right? That function right there. So the work then is on the right side, just integrating that information over there. And hopefully that won't be too difficult. All right. So what do we do? If it's linear, determine that the differential equation is linear. Find the integrating factor. Is mu equal to e raised to the power of the integral of p of x dx. Multiply everything in the differential equation by the integral. The left side, there's no work on the left side. The left side is automatically the derivative of the product of the integrating factor and the dependent variable y, equal to the integral of the right side. Integrate the right side. And then from there, just simplify, you get the answer. The integrating factor forces the dE to be exact. So the left side is an exact differential. So that's why it's easy for us. So there's no work for us to do. Let's take a very simple problem. Let's take number 4, and then we'll build on that. if the differential equation is linear, it has to be written in that form. It has to be written in that standard form for a linear first order differential equation. This is not in the standard form because there's a 3 there. The standard form says that you got to have dy over dx by itself plus some function of x, p of x, times y is equal to some function f of x. Well, this 3 has to go, right? Look at number 10, the x has to go. Right? So here we divide everything for number 4 by 3. We get y prime plus 12 divided by 3 is 4y. This is equal to 4 over 3. Determine the integrating factor. So mu is equal to e to the integral of p of x. P of x is just 4. This is 4 dx. So the integrating factor is e to the 4x. So I multiply everything in this differential equation by the integrating factor. Now what I do is I just write it all out for this problem, and then hereafter just show you just the shortcut and just go right to it. So this is e to the 4x. You know that y prime is dy over dx. Just like to write y prime because it's shorter. Plus 4 times e to the 4x times y is equal to 4 over 3 times e to the 4x. I'm going to show you something because I know you don't believe me, and so I have to show you, right? And that's good. You don't want to believe everybody anyway, right? Until they show you, or you show yourself that what they're saying is true. I'm going to show you that the left side is indeed the derivative of the product of the integrating factor and the dependent variable y. Let's look at the left side. Let's come over here and just write it. Just the left side. So this is e to the 4x dy over dx plus 4 times e to the 4x times y. Now, if I take the derivative of the product of the integrating factor e to the 4x, e to the 4x, e to the 4x times the dependent variable y, and just work that out. Just use the product rule and let's see what we get. So take the derivative of the first. That's going to be 4 times e to the 4x times y. 4 times e to the 4x times y plus times the second, then plus now the first, e to the 4x times the derivative of the second times y prime. Isn't that the same as this statement right here? They're the same, right? So what you get when, again, remember the integrating factor, it's going to force the differential equation to be exact. So that left side is an exact differential. So that left side, that simply means that it's simply the derivative of the product of the integrating factor times the dependent variable y. So for this left side, all you have to write is this. This is the derivative with respect to x of the integrating factor e to the 4x times the dependent variable y is equal to 4 over 3, which was our f of x, times the integrating factor e to the 4x. So now, that's a 4, not an 8, I'm sorry. So now I integrate both sides. So we integrate the derivative, and all we have left is e to the 4x times y. E to the 4x times y. I integrate 4 over 3, which just put that out in the front. So I'm actually integrating e to the 4x. So the integral of e to the 4x is 1 over 4 times e to the 4x times 4 over 3. So this is 4 over 3 times 1 over 4 times e to the 4x plus c. Divide through by e to the 4x. And so I have left just y. See, this implies that this is y is equal to, well, 4 over 3 times 1 over 4 is just 1/3. Dividing through by e to the 4x, I just have left a 1/3 plus c times e to the negative 4x. And these questions, this is 2.3. It says find the general solution of the given differential equation. Give the largest interval I over which the general solution is defined. Determine whether there are any transient terms in the general solution. You make mention of what they mean. And just make mention of that, and then I'll come back and tell you what that is for this particular problem. A term is said to be transient if C, the constant, if C times this is some function, let me make up a function, C times alpha x, let's call it that, because it might not just be exponential. So if C times alpha of x goes to 0, so if that term that's multiplied to the constant, if that term, if its limit goes to 0, as the term n or t or whatever the value may be, as n goes to infinity. So a term is said to be transient if that constant term, if that guy goes to 0 for its limit, right? If it goes to 0, we say that it's transient. If it doesn't go to 0, then it's not transient. So in Web Assign, it asks that question, is it transient? And if it is transient, then you would type in C times whatever that is in the problem. If it's not transient, you would just say none, N-O-N-E. And then they will also ask for the interval, the largest interval, whereby the solution is said to exist. And that typically just boils down to determining where the solution function is discontinuous, and just exclude that. So if you got, like, say for example, the answer is like 2 over x, well, you can't include 0. So the solution would be from negative infinity, 0, open interval, right? Union with open interval 0 to positive infinity. If the answer is the square root of x, then the interval for the solution would be open interval from 0 to positive infinity. So very basic. So let's go back and look at that. So for this problem, you see the transient term here. So here, sorry to go up, but notice that C times e to the negative 4x goes to 0 as x goes to infinity. So this part is said to be transient. Now, the interval for the solution would be just look at y equal to 1 over 3 plus c times e to the negative 4x. What values of x will constitute a solution value for y? All real numbers. Right? So here the interval goes from negative infinity to positive infinity. Well, I had wanted to do 10, but I got a lot of stuff around it, so let's look at number 3. So number 3 is already in the form for a linear equation. So mu is equal to e to the integral of p of x. What's p of x for this problem? 1. So it's just 1 dx. We'll just say dx. So this is equal to, mu is equal to e to the x. So here's what we do. Well, I better write it all out, and then I'll do my little trick. So we multiply everything by the integrating factor, e to the x times, just right there as y prime, plus e to the x times y is equal to e to the 3x times e to the x. Well, that's just e to the 4x, right? The left side is automatically the derivative of the product of the integrating factor and the dependent variable y. And that's equal to e to the 4x. Integrate both sides. So we integrate both sides. The left side is just e to the x times y. And the integral of the right side is just 1 over 4 times e to the 4x. You know, with that, just like the previous problem, you have to use a u du substitution, right? That's how we get the fraction. So 1 over 4 times e to the 4x plus c. Divide everything through by e to the x. We get y is equal to 1/4 plus c times e to the negative x. And yes, it is transient, because this factor, c times e to the negative x, excuse me, I goofed. This guy does not go to 0. It does, because e to the 4x is on the bottom. Okay. I'm thinking about e to the positive 4x, and it goes to infinity. It goes to 0. Okay, all is good now. Okay. I hadn't had my brain collapse yet. So yes, this guy is transient, and that term is c times e to the negative x. And the interval, so-called solution interval, this guy would also be the same, from negative infinity to positive infinity. Any questions? Let's look at another one. Let's take number 6. It's already in the standard form. The standard form, the key is that whatever is multiplied to y prime has to be 1, right? So if there's a term there, you divide it through the differential equation. So here mu is e to the integral of 2x dx. So this gives us e to the x squared. And so here's how I do it. I just jump right to it. The left side is the derivative of the product of the integrating factor e to the x squared times the dependent variable y is equal to, remember, I'm multiplying both sides by the integrating factor. So this is x cubed times e to the x squared. Integrate both sides. All right, so the left side is e to the x squared times y. That's equal to, what's the integral of x cubed times e to the x squared dx? What is that integral? What is that integral? All right, let you think about that. All right, number 7. This is not in the form, so we write this as y prime plus divide everything through by x squared, so we get 1 over x times y is equal to 1 over x squared. The integrating factor, mu, is e to the integral of 1 over x dx. This is equal to x. Uh-oh. Do you see that? That's just x. Right? You see that's what? E to the natural log of x. And what's e to the natural log of x? Just x, right? So we multiply everything through by the x. So the left side is automatically the derivative of the product of the integrating factor, which is x, times the dependent variable y, is equal to 1 over x squared times x. So that just gives me 1 over x. Integrate both sides. So the left side is x times y is equal to the natural log, the absolute value of x, plus c. Divide everything through by an x, and so y is equal to 1 over x times the natural log of the absolute value of x plus c all over x. Is it transient? Yes. C over x goes to 0 as x goes to infinity, right? So it's transient. And the interval is based on the natural log. The natural log goes from 0 to positive infinity. So this is open interval from 0 to positive infinity. Any questions there? All right. Let's take one more. It's work number 11. and then we'll move on. Number 11 is not written in the form. We have to divide everything through by an x. So this is y prime plus 4 over x times y is equal to x cubed minus 3 divided by x is just x squared minus 1. The integrating factor is x to the 4th. Do you see that? Well, probably not. So let's see. So we got mu is equal to e to the integral of that 4 over x dx. 4 over x dx. This is e to the integral of 4 times the natural log of x. Don't need the, just integrate it. Don't need the integral sign anymore. So this is, we integrate that, we get 4 times the natural log of x, which is e to the natural log of x to the 4th. And that's just x to the 4th, right? So you multiply everything through by x to the 4th, and I better put that in there and not skip a step. I'm sorry. X to the 4th times y prime plus x to the 4th times 4 over x times y is equal to x to the 4th times x squared minus 1. The left side is automatically the derivative of the product of the integrating factor, which is x to the 4th, times the dependent variable y. And that's equal to x to the 6th minus x to the 4th. Integrate both sides, and that leaves us, if I can just go here, this is just x to the 4th times y is equal to the integral of x to the 6th, excuse me. X to the 6th minus x to the 4th dx. We integrate that. That's just x to the 7th over 7 minus x to the 5th all over 5 plus c. So divide through by that x to the 4th, and we get y by itself. Y is equal to x to the 7th divided by x to the 4th is just x to the 3rd all over 7 minus x to the 5th divided by x to the 4th. That's just x to the 1st power all over 5 plus c all over x to the 4th. Is it transient? Yes, it is, because that c over x to the 4th does go to 0 as x would go to infinity. What about the interval for the solution? Except 0, because you got x to the 4th downstairs, right? So all real numbers except 0. Okay. Any questions there? Well, there's a lot of problems here. Let me just conclude with this problem, since it has some trig functions in there. Let's see how that works out. So this is a function of theta. R is the dependent variable, and theta is the independent variable. Well, the coefficient of dr over d theta is 1, so that's what we like. So P of x would be this secant theta. Well, P of theta, I guess I should say. So you can write this as dr over d theta plus secant theta times r is equal to cosine theta. So everything matches up. So mu is equal to e to the integral of secant theta d theta. So the integral of secant theta is the natural log of secant theta plus tangent theta. So this is e to the natural log of secant theta plus tan theta. And so that just gives us secant theta plus tan theta. So we multiply everything through by this integrating factor. So secant theta plus tan theta times dr over d theta plus secant theta plus tan theta times secant theta times r is equal to secant theta plus tan theta times cosine theta. Well, the left side is automatically the derivative. Here, this is the derivative with respect to theta of the integrating factor, which is secant theta plus tan theta times the dependent variable, which is r, is equal to basically that right side, which was cosine theta, times the integrating factor, secant theta times tangent theta. Now, if you will, I want to write it out. So secant theta is 1 over cosine plus, and tan is sine theta over cosine theta. Just write that integrating factor out, times cosine theta. And so the left side again would simplify that right side over there. Secant theta plus tan theta times r, that's equal to 1 plus sine theta. Well, that'll help us out in integrating that right side. Won't be so difficult now. So we integrate both sides with respect to theta. And if it's okay, I just want to write the left side. When I integrate that derivative, I just get what's inside the brackets, right? I'm just going to write that. Is that okay? Faija, is that okay? Okay. So this is secant theta plus tan theta, that's times the r, that's equal to the integral of 1 plus sine theta d theta. Well, that right side, you can just work that out. That's theta minus cosine theta plus c. So we get secant theta plus tan theta times r is equal to theta minus cosine theta plus c. I mean, you can leave it, this is minus. You can leave it like that, or you can divide both sides by that secant theta plus tan theta. So I'll just say or r is equal to theta minus cosine theta plus c, and that's all over secant theta plus tan theta. And I want to say in the back of the book, I think he writes his answer like that. Either, like, so I just said or. It doesn't matter. All right. Well, I want to stop there and then just cover the last section, and then we'll be done for today. Okay.